Question 3. Balance the following chemical equations. Sodium hydroxide plus sulfuric acid gives rise to sodium sulfate plus water. Potassium chlorate gives rise to potassium chloride plus oxygen. Mercuric nitrate plus potassium iodide gives rise to mercuric iodide plus potassium nitrate. Let us take the chemical equation. NaOH plus H2SO4 gives rise to Na2SO4 plus H2O. To balance this equation, we draw a table containing elements involved in the equation, number of atoms of reactants and number of atoms of products. This chemical equation has following elements. Sodium, number of sodium atom on reactant side and product side are 1 and 2 respectively. Similarly, for oxygen 5 and 5, for hydrogen 3 and 2, for sulfur 1 and 1. We observe that sodium and hydrogen are not balanced. To balance sodium, we multiply with 2 on reactant side of sodium atom. By this, oxygen atoms on reactant side becomes 6, hydrogen becomes 4 and sulfur remains 1. After this, we observe that hydrogen and oxygen are not balanced. To balance hydrogen, we multiply with 2 on product side of hydrogen. By this, oxygen atom becomes 6 on product side. By this, all atoms are balanced on both sides of the chemical equation, and the balanced equation is 2NaOH plus H2SO4 gives rise to Na2SO4 plus 2H2O. Balancing KClO3 gives rise to KCl plus O2. To balance this equation, we draw a table containing elements, number of atoms of reactants and number of atoms of products. Chemical equation has following elements. Potassium, that is K. Number of potassium atoms on reactant side and product side are 1 and 1. Similarly, for chlorine it is 1 and 1. For oxygen it is 3 and 2 respectively. We observe that oxygen is not balanced. To balance oxygen, we multiply with 2 on reactant side. By this, oxygen becomes 6, chlorine becomes 2 and potassium becomes 2 on the reactant side. On product side, we multiply with 3 to the oxygen molecule so that oxygen is balanced on both sides. K and Cl are not balanced. To balance chlorine and potassium, we multiply with 2 on product side. Finally, the balanced chemical equation is 2KClO3 gives rise to 2KCl plus 3O2. Balancing Hg, NO3 taken twice plus Ki gives rise to HgI2 plus KNO3. To balance this chemical equation, we draw a table containing elements, number of atoms of reactants and number of atoms of products. For mercury, that is Hg, we have 1 and 1. For nitrogen, we have 2 and 1. For oxygen, we have 6 and 3. For potassium, we have 1 and 1. And for iodine, we have 1 and 2 respectively. We observe that nitrogen, oxygen and iodine are not balanced. To balance oxygen, we multiply with 2 on product side. Then oxygen atom becomes 6, nitrogen becomes 2 and potassium becomes 2 on product side. By this, Hg is balanced, N is balanced, O is balanced, K is not balanced, I is not balanced. So, to balance K, we multiply with 2 on reactant side, then potassium atoms become 2 and iodine atom becomes 2 on reactant side. Finally, the balanced chemical equation is Hg, NO3 taken twice plus 2Ki gives rise to HgI2 plus 2KNO3.